Every engineer trained in Detroit, Stuttgart, or Tokyo learns the same unbreakable law on day one. If you want real power out of a gasoline engine, you have to accept wasting fuel just to keep the combustion chamber from melting itself alive. That's not a design flaw. That's supposedly physics. Nobody breaks it. Nobody's ever been able to. While the rest of the industry burns tens of billions of dollars on electric platforms that customers keep refusing to buy at the volume anyone predicted, Mazda just launched a direct counterattack, and it's aimed straight at that supposedly unbreakable law. The 2027 CX-5 is arriving with a new engine called Skyactiv-Z, and Mazda is calling it the closest thing to a combustion masterpiece the industry has ever produced. Impossible tech, running the chemically perfect air-fuel ratio under real load, paired with an in-house hybrid system built specifically to kill the CVT compromises that have plagued every rival hybrid on the market. No borrowed parts, no shortcuts. Mazda's engineers apparently looked at the industry's supposedly unbreakable rule and decided to break it anyway. So, here's the question we're answering today. Is this the engineering masterpiece of the century, or is Mazda about to bet its most important nameplate on a billion-dollar suicide mission?
The heat problem. Here's the physics Mazda is up against, and once you understand it, you'll understand exactly why this claim is so explosive. Gasoline burns cleanest and most completely at a specific ratio, roughly 14.7 parts air to 1 part fuel. Engineers call this stoichiometric combustion, or Lambda 1. It's the sweet spot: full combustion, minimal waste, maximum efficiency, and the cleanest possible burn. The problem is heat. The moment you demand real power, merging hard onto a highway, climbing a mountain grade, towing anything with weight behind it, the engine chamber effectively turns into a foundry. Exhaust gas temperatures spike to the point where they can melt a catalytic converter or trigger destructive knock inside the cylinder walls. So every automaker does the exact same thing to survive that heat. The ECU floods the chamber with extra, unburned gasoline. That fuel isn't there to make power. It's dumped in purely as a liquid coolant, sacrificed on the spot just to keep the engine from destroying itself from the inside. This is exactly why the current wave of small turbocharged engines, the 1.5-liter and 2.0-liter turbos everyone's been sold on for the last decade, post fantastic numbers on the EPA's gentle, controlled laboratory cycle, then completely fall apart the moment you actually drive like a real person. On paper, they look like fuel-sipping marvels. On a real highway on-ramp, the instant boost pressure builds, fuel enrichment kicks in right alongside it, and your real-world mileage quietly collapses, while the engine also absorbs extra long-term heat stress it was never designed to handle constantly. For decades, this wasn't treated as an engineering problem waiting to be solved. It was treated as a wall, a hard physical ceiling nobody could design their way past. Engineers across every major automaker assumed continuous Lambda 1 operation under real, sustained load was simply impossible. You either strangle output to protect the engine, or you let it cook itself apart from the inside out, cylinder by cylinder, mile after mile. That's the wall Mazda is now claiming to have broken in a mainstream family SUV, not a million-dollar prototype. Inside Skyactiv-Z. So how does Skyactiv-Z actually pull this off? Two systems working together, both attacking the same problem from opposite directions. The first is flame front control. Running a lean stoichiometric mixture at high load is dangerous precisely because lean mixtures are unstable. They're prone to exactly the kind of uncontrolled, violent knock that destroys pistons. Mazda's approach is to precisely manage how and where the flame actually propagates through the chamber, keeping the burn stable and predictable even when the engine is under real strain, instead of letting it spike unpredictably the way a standard lean burn setup would. The second is thermal energy recovery. rather than simply venting the heat generated by combustion out through the exhaust and cooling jacket as pure waste, which is what every conventional engine does. Skyactiv-Z is engineered to capture and redirect that thermal energy, reducing the temperature spike that would otherwise force the ECU to reach for the fuel enrichment safety valve in the first place. Attack the heat at the source, and you remove the reason the engine ever needed to cheat.
The emissions case is just as aggressive. Skyactiv-Z is being engineered to meet Euro 7 in Europe and America's brutally strict LEV4 and Tier 4 standards without choking the engine down to hit those numbers. That's the part that matters. Mazda isn't detuning its way to compliance. It's claiming to clean the combustion process itself. And if this sounds like marketing spin dressed up as engineering, remember, Mazda has already pulled off a version of this exact move before. Back in 2011, Skyactiv-Z shocked the entire industry by running a 14:1 compression ratio on regular pump gasoline, a number most engineers at the time insisted would just detonate itself apart. It didn't. It became one of the most efficient naturally aspirated engines on the market. That's not a coincidence, and it's not luck. Extreme, unconventional combustion engineering is Mazda's actual core competency. It's the one thing this company does that nobody else in the industry has been willing to seriously chase. Now, if you've been following Mazda closely, you're probably thinking of Skyactiv-X right now, the compression ignition engine with the exotic SPCCI system that Mazda sold in Europe and never brought to North America, largely because it was expensive to build and picky about fuel quality. Skyactiv-Z is not that engine, and it's not chasing the same approach. It drops the costly SPCCI hardware entirely and focuses purely on holding a practical Lambda 1 ratio across the rev range, running on standard North American pump gas without the price premium or the fuel quality headaches that helped sink Skyactiv-X commercially. This is the lesson from that failure applied, not repeated.
The in-house hybrid. Here's where it gets more expensive and more revealing about how serious Mazda actually is. The current CX-50 hybrid runs on a Toyota-sourced hybrid system, proven, reliable, and cheap to license. For the next generation CX-5, Mazda is walking away from that exact system and building its own hybrid powertrain completely in-house instead. Think about what that decision actually means. Toyota's hybrid tech works, it's everywhere. Using it on the CX-50 was the smart, low-risk business decision. Ripping it back out for the CX-5, Mazda's single highest volume model on the planet, and replacing it with an unproven in-house system is not a cost-saving move. It's a statement. And the reason comes down to something Mazda owners have been furious about for years: the rubber band feel of e-CVT hybrids like the Toyota RAV4 hybrid and Honda CR-V hybrid. Plant the accelerator in one of those, and the engine flares up into a flat, monotone drone while the car only vaguely, gradually catches up. No crisp connection between what your foot is doing and what the car is actually doing underneath you. For most buyers, that's a minor annoyance. For Mazda, whose entire brand identity is built on Jinba Itai, horse and rider moving as one, an e-CVT that lets engine revs float independently of actual road speed isn't a minor annoyance. It's a direct contradiction of everything the brand claims to stand for. There's also a real hole this engine has to fill, and Mazda knows it. The CX-5's beloved 256 horsepower turbocharged 2.5, an engine with a genuine cult following among owners who cross-shopped it against far pricier performance crossovers, is being phased out as the lineup transitions. Early reporting around the program points towards competitive combined system output, putting it right in the fight with the CR-V hybrid and RAV4 hybrid, with the electric motor doing the heavy lifting off the line, so there's zero lag waiting for the combustion side to build response.
Critically, Mazda is developing the hybrid system in-house rather than simply carrying over Toyota's existing setup, paired with the same standard iActive AWD system that already sends power to whichever wheel needs it, so torque gets distributed instantly instead of being smeared through a rubber band gearbox. The target isn't just matching the old turbo's numbers, it's making sure loyal CX-5 buyers don't feel like they got downgraded just because the badge changed from turbo to hybrid.
Hybrid versus EV reality. Let's talk about the cost of ownership nobody wants to say out loud. EV advocates love to cite cents per mile numbers that assume you're charging exclusively on cheap overnight home electricity. That's not how most people actually live. Factor in public DC fast charging rates, which spike hard during peak demand hours, and the real cost per mile gap shrinks fast. Factor in the accelerated tire wear that comes from hauling around several hundred extra pounds of battery pack, and it shrinks further. And factor in what happens to a battery pack's usable range the moment temperatures drop below freezing, a real-world hit that can gut your range right when you need it most, and the picture EV marketing paints starts looking a lot less complete. Now put a Skyactiv-Z hybrid CX-5 next to that. Fuel economy that closes in on what it actually costs to run an EV per mile once you account for real-world charging costs with none of the asterisks. No range anxiety on a long trip. No gambling on whether the nearest fast charger is actually working, actually available, or actually fast when you show up and need it. Just a 3-minute stop at any gas station anywhere in the country, in any weather, and you're back on the road. And this is where Mazda goes on offense, not just defense. Pair that efficiency with the CX-5's already well-regarded near-luxury cabin, soft touch materials, quiet cruising refinement, a driving position that doesn't feel like an economy compromise, and you've got a genuine threat to buyers who are about to overpay for the badge on a Lexus NX or a BMW X3 just to get a nicer interior and a smoother ride. To be fair, Mazda's shift toward a bigger touchscreen and fewer physical buttons has drawn some real criticism from longtime owners who preferred the old dial-and-button layout. That's a legitimate trade-off, not a footnote. But the material quality and cabin sound insulation still sit well ahead of anything else in the mainstream compact SUV segment. Mazda's pitch is simple. Get that same feeling for a lot less money with none of the charging infrastructure headaches and none of the winter range anxiety.
Mazda's master plan. Understand exactly what's on the line here. The CX-5 isn't a side project or a low-volume halo car where a failed experiment quietly gets forgiven. It is, and has been for years, the single biggest volume driver in Mazda's entire global lineup, the vehicle that props up the balance sheet while the rest of the range figures itself out. Staking that nameplate's next generation on an unproven, genuinely difficult combustion architecture isn't a cautious hedge-your-bets move. It's Mazda putting its most important product on the table as proof that it has actually solved something the rest of the industry quietly gave up trying to solve. And that's what makes this bigger than one engine and one SUV. While competitors that bet everything on aggressive, near-term EV targets are now writing down billions of dollars and delaying launches they once called inevitable, Mazda scaled back its own electrification spending and poured that capital back into combustion engineering, a direct, public bet that mechanical innovation still has real room to run, even in an era where every headline insists the internal combustion engine is already dead. Here's the closing statement, and I mean this one. The internal combustion engine was never actually dying. It was just waiting for one automaker stubborn enough and honestly reckless enough to keep pushing on a problem everyone else had already decided was unsolvable. Before you head to the comments, hit subscribe. This channel is tracking every one of these combustion versus electric power plays as they happen, and you do not want to miss the next one. Because here's the real fight I want to see play out below.
Are you on the side that thinks Mazda just proved mechanical engineering still has room to evolve, or are you on the side that thinks this is a company stubbornly refusing to accept that the electric future has already been decided? Pick a side and defend it in the comments. And if you want to see the automaker that made the exact opposite bet, going all in on electric while Mazda doubled down on gasoline, stick around because that breakdown is coming next and the contrast is going to surprise you.